Welcome to the first module of the module 4, infinite series and power series solution. First, let us know what is the infinite series. Consider an infinite sequence, that is un, then the infinite sum, that is u1 plus u2 plus etc. plus un of the members of the sequence is called infinite series or simply series, and this is denoted by summation un or simply summation un. Let us see the example. Summation 1 upon n is equal to 1 upon 1 plus 1 upon 2 plus etc. This is the example. Now, what is the nature of the series? We have two types of series. One is the convergent series, another one is a divergent series. The series is convergent if the sequence Sn is convergent, that is, limit of Sn is equal to L is finite and unique. The series Un is divergent if the sequence Sn is divergent, that is, limit of Sn is equal to plus infinity or minus infinity. Next is P series test. The series summation 1 upon n power p is called a P series. If p is greater than 0, greater than 1, then it is convergent. If it is less than or equal to 1, then it is divergent. Example, summation 1 by n is divergent and summation 1 by n square is convergent. Tests for convergence. In order to test the nature of the given series, whether it is convergent or divergent, we use the following tests. First one is a D'Alembert's ratio test. Next, we have Cauchy's root test. D'Alembert's ratio test. If un is a series of positive terms and limit un plus 1 by un is L as n tends to infinity, then if L is less than 1, the series is convergent. If L is greater than 1, the series is divergent. If L is 0, then the test fails. Let us look into the example. Test the convergence of the series 1 plus 2 factorial by 2 square plus 3 factorial by 3 square plus 4 factorial by 4 square and so on. In order to test this whether it is a convergent or a divergent, we have to first write it in the form of un. What is un is equal to? It will be n factorial divided by n to the power of 2. This is power n. So un is equal to n factorial by n power n, and un plus 1 is n plus 1 factorial divided by n plus 1 whole to the power of n plus 1. Before we could proceed further, we need to recollect the two formulae we have. Basically, we have learned the two formulae. One is limit n tends to infinity, 1 plus 1 by n to the power of n is equal to e. Limit as n tends to infinity, 1 plus x by n to the power of n will be e to the power of x. These are the two basic formulae which we have to apply while solving this problem. So let us consider un plus 1 divided by un, that gives us n plus 1 factorial by n plus 1 to the power of n plus 1 into n to the power of n divided by n factorial. That gives us n plus 1, that is n plus 1 factorial can be also written as n plus 1 into n factorial divided by this n plus 1 to the power of n plus 1 can also be written as n plus 1 to the power of n into n plus 1 to the power of 1. Cancelling n plus 1 and n plus 1 and n factorial and n factorial, we get n power n divided by n plus 1 whole power n. Now, in order to test whether it is a convergent or divergence, we have to take the limit as n tends to infinity. So, before we take the limit, we can take some term common, that is n power n, both from numerator and denominator. When we take that common, we get un plus 1 divided by un as 1 divided by 1 plus 1 by n to the power of n. Now let us take the limit as n tends to infinity. So we get limit as n tends to infinity, un plus 1 divided by un is equal to limit as n tends to infinity 1 divided by 1 plus 1 by n to the power of n, which is equal to 1 divided by e is less than 1. By D'Alembert's ratio test, the summation un is said to be convergent. This is how we can test the results for the various problems. Thank you. In the next video, I will discuss some more problems based on the D'Alembert's and Cauchy's test. Thank you all.